Hi friends, welcome to my channel. Let's have a look at problem 23, merge key sorted lists. In this video, we're going to practice the use of dummy node and comparison again. So we're going to provide two formats of solutions. So the first format is based on PriorityQueue, and the second format is based on min heap. So with that said, let's first look at the statement of the problem. So we are given an array of key linked lists called lists. So each linked list is sorted in an ascending order. So we are required to merge all the linked lists into one sorted linked list and return it. So here are three examples. So example 2 and 3 are basically edge cases. So let's focus on example 1. So in example 1, there are three linked lists, so represented by 1, 4, 5. And 1, 3, 4 and 2, 6. So after merging, so we get 1, 1, 2, 3, 4, 4, 5, 6. So the additional constraints are mainly about the problem size. For example, k is the number of linked lists we are going to deal with or merge. So k is bounded above by 10 to the power 4. And the values of the nodes in this linked list is bounded in between negative 10 to the power 4 and positive 10 to the power 10 to the power 4. And each of the linked lists is sorted in ascending order. So this is actually an important assumption. So the last one is about the total nodes in all these linked lists. So it's not exceed 10 to the power 4. So with that said, let's look at the solutions we are going to share and do a line-by-line analysis. So we're going to use the dummy node for convenience, and we need to use comparison because of the problem requirement, that is merging the nodes according to their nodes value from small to large. So we're going to share two methods or solutions formats based on PriorityQueue and min heap respectively. So here is a remark. So we are going to use dummy node here like in leetcode 21. So actually you are welcome to check out the video for leetcode 21. But we need to impose a comparison relation in the list node object. So if we look at the implementation or what provided in this problem, the list node class does not implement the down less than method. So in order to use these two abstract data types, we are going to use a wrapper class or boxing to implement this simple method. So before we look at the code, actually here is a book which actually is very helpful to check this abstract data types. So that's the algorithms, the fourth edition by Sedgwick, so from Princeton University. So with that said, let's look at the two solutions. So for the first format of solutions, I'm going to use the PriorityQueue. So I import this container here. And then, as we mentioned, we're going to use a wrapper class or boxing to include a down less than method. So for that, we can choose to put this wrapper class outside this solution class or within this solution class. So here I'm choosing to include it into the solution class. So first, let's use this wrapper class or boxing like in Java. So this actually imposes comparison or order in list node object. So this is actually very simple. So we are going to implement a class called boxing, and then in its initializer, so we're going to pass a node to it, list node. So self node to be the node. So this is the initialization, and then we're going to implement the down less than method. So self. So we're going to accept another list node or boxing object. So we're going to return so self node value is less than other node value, right? So this is a Boolean function. So with that said, actually we are done the wrapper class or boxing. So next, what we are going to do is some preparation. So for this preparation, so we are going to initialize a dummy variable. Let's call it this node. So I'm going to use a value which is out of this range, right? So I can do the 10 to the power 4 minus 1. And then I'm going to initialize a PriorityQueue container. So here actually the default behavior is that the PriorityQueue is unbounded, corresponding to max size equals 0. So otherwise it has a specific bound. So let's keep this default. So notice that this maximum size is 0, means that the PriorityQueue is unbounded. So with that said, so we can first add the linked list to the PriorityQueue. So basically for head in lists. So we're going to check if this head is not null. So if it's null, we do not do anything. So otherwise, we're going to put the head into the PriorityQueue. So put this, we're going to put a boxing object. So with the initialization to be, with the data to be the head node. So this way, or to be emphasizing again, so this wrapper class enable us to use the PriorityQueue and the latter min heap container. So this is the preparation step. So the next step is basically the merge, the actual work. So for this, actually it's very routine to problem 21. Let's do it here. So first we introduce another variable. It's a running variable. It's called current. It's initially pointing to dummy. Then if the PriorityQueue is not empty, in other words, not queue empty, then first we are going to get the element with the lowest priority. So notice that in the Python implementation, so the element with lowest priority is first accessed or retrieved. So head equals queue get. So here what we get actually is a boxing object. We need to get the node. So this is the first. Then because we are going to connect the current with the head, so then we need to put the head next to the PriorityQueue. So let's first introduce a variable called follow, so to be null. And then what we want to do is if head next is not null, so we are going to set follow to be head next. And then what we are going to do is that we are going to break the link. So we are going to set head next to be null. So that's the purpose for this follow, right? So we are going to break the link and then connect current next to be the current head, and then we reset the current to be head. So that's the main operations we're going to carry out in this while loop. So let's go over it again. So we get the head, and then we get its next node, and then we break the link, and we connect the current with the current head, and then we set the current to be the head. And then what we are going to do is we check if follow is not null. Then we are going to enqueue this one to the PriorityQueue. So queue put. So notice that we are going to put a boxing object. So that is boxing follow. So that's the main operation. So with that done, actually we are ready to return the result. So what we are going to return is nothing but dummy next. So that's also the point of using a dummy node. So with that said, let's first do a special case check. Yeah, it passes the first example. Now let's do a generic case check. Yeah, it passes all the generic cases. So here let's quickly summarize this solution. So this solution is based on PriorityQueue, and we implement a wrapper class so which imposes order so that we can use the PriorityQueue container. And then we made some preparations to initialize the queue and introduce a dummy variable. And the third part is the main merge operations. And finally, we return the result. So actually, it should be noticed that here we break the link and can be important for this problem, right? So then basically this part follows the same strategy as in problem 21. So with that said, actually we finished the first solution. So let's copy this class and the function signature, and then change this one to be, let's call this one v1. Then for the second solution, we're going to use min heap. So actually, some of the PriorityQueue implementations under the hood is related to min heap. So here, for this, I'm going to first import the heapQ class. Import heapQ. So this is the standard, right? We're going to use a min heap. So again, we're going to need the boxing or wrapper class. Let's copy this here. What we need actually is the dunder less than method. So that's it. So next, what we're going to do is that again, preparation. So for this preparation, so I'm going to copy this. I'm going to use this same dummy node as above. That is list node. So we're going to use value to be negative 10 to the power 4 minus 1. And this time, what we're going to initialize is a heap, right? So then we're going to first do some initialization. So for hide in lists, so we need to put this hide into the heap. So basically, it's the same strategy. If hide, so we're going to use heap q, heap push. So we pushed something to this heap, and the thing we're going to put in is boxing hide, right? So this is actually parallel to the above solution. So the third step is also parallel, so merge. So basically, we set a current variable to be the current dummy, and then do the while loop. While heap is not empty, then we're going to first get the hide list node. So we're going to do heap q heap pop from this heap. So notice that what we get after the pop operation is a boxing object. We need to retrieve the node, right? Then again, we are using the same strategy. We introduce a follow, set it to be null, and then we check if head next. Then we're going to set follow to be head next. And then what we want to do is to break the link. So we set head next to be null after we have set this follow variable. So next, what we are going to do is routine. We are going to connect current to the current hide, and then so we reset the current state to be the current hide. So then what we need to do is that if follow is not null, in other words, so after the head, the follow representing another list without head is still not empty. So in this case, we're going to do heap push operation. Heap push. So we're going to push things into this heap. What we are going to push is the boxing of the follow. So notice that this second format is essentially the same, but using slightly different container. So next, we're going to do the return. So what we are going to return is again dummy next. So essentially the same with slightly adjustment of code or method calls. So let's do a special case for this format of solution. Yeah, it passes the first example. Now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this for the solutions to this problem. So here we shared essentially the same solution using two different containers. So the first one is based on PriorityQueue. So the second one is based on min heap. And in both of the two solutions, actually there are some common ingredients like the use of dummy node and using boxing or wrapper class to introduce comparison. And finally, so in the merge operations, there's one important thing, that is breaking the link. So with that said, I guess that's about it for this video. And thank you very much.